Now, summary of the mass concentration from the different sampling sites show that in the year 2021, Adabaka recorded a very high concentration levels with respect to, and that was 60.76. That was about almost, let's say, almost 4 times the interim targeted, WHO limit, and almost about twice that of Ghana's standards. And that was followed by Dansuman, which was at a mass concentration level of 49.9, followed by that of University of Ghana. So even though University of Ghana had the least of 42.49, it is still far above the interim targeted level of WHO, and then that of Ghana's standards. Same trend was observed for the 2022 sampling period. Now, this box plot also depicts the same idea that the average mass concentration at the different sampling locations were all far above the interim targeted value of 15 micrograms per cubic meter for WHO, and that of 35 micrograms per cubic meter for Ghana standards. So on the plot, the broken lines or the dotted lines depict the interim targeted value for WHO, and then the firm line here depicts that of Ghana standards, and you can see that they are all below the average mass concentration at the 3 different locations. Now, this diagonal plot also show that there were some spikes during the 2021 sampling period around December, and then also in 2022 around December and then January, and that could possibly be attributed to the inflow of the harmattan dust during the dry seasons. Now, the elemental analysis from the SRF results also gave this species that were plotted against their concentrations. And then in the year 2021 to 2022, with respect to data collected from the University of Ghana sampling location, it tells that aluminium were quite prominent in the SRF analysis, as well as iron, potassium, sulfur, silicon. At the Dansuman sampling site, data collected also show high levels of aluminium, iron, potassium, sulfur, and then silicon, as well as chlorine. Can you roll over the slide, please? Next slide. Right. So my work involved the usage of PMF for the source apportionment, but I also have to touch on the fact that we have other receptor tools or models that could also be used for the determination of sources of these pollutants. Now, to successfully have or go through the source apportionment, there are some marker elements that could be used or that were used to help identify the sources and then their contributions. And these are some of the marker elements. So it means that if you have the presence of aluminum, silicon, scandium, titanium, iron, then it means that you have soil dust being present, or the source of that pollution or the source of that pollutant is from soil. And we have calcium, aluminum, sulfur, scandium, silicon, titanium, iron, also telling that the source is from road dust. And then the sea salt also tells that if you have sodium, chloride, bromide, sodium, magnesium, it means that you have the source coming from the sea, and so on and so forth. Now, so the PMF analysis showed this. Now, the sketch on the right shows the fingerprints of the source profiles, right? And then if you look at the first one on top, it talks about soil dust. So if you look on the horizontal axis, it tells that we have some levels of elements that were used from the marker elements to be able to identify those sources as coming from soil dust and then other sources. So University of Ghana from the source profile shows that high levels of, or the majority of the sources was from soil dust, followed by biomass burning and fossil fuel, as well as solid waste burning. A similar trend was seen in the year 2022 from the University of Ghana sampling sites. Now, for the Dansoman sampling location, after the analysis, sea salt spray was seen to have the highest percentage with respect to the source of pollution, followed by solid waste burning, soil dust, waste suspended soil, and then biomass. And this could be attributed to possibly wind blown across the sea, which is closer to the Suman, and of course, food vendors that also make use of biomass in the heating and cooking. And then there's road dust, soil dust that is blown from the streets, and then some on paved surfaces. A similar trend was observed for the 2022 sampling period for Dansoman. Now, in conclusion, I'll say that all the mass concentrations data from the different, for the 3 sampling sites showed that they were all above the interim targeted level of 5 micrograms per meter with respect to WHO standard, and as well as that of Ghana standards. And then it shows that, or it also tells that the inhabitants of Accra are exposed to high levels of this ambient particulate matter that could, be detrimental to their health. And then the soil dust was seen as the highest among the sources of pollution at UG for the 2021-2022, and as well as sea spray being the highest among the source of pollution for the Dansoman sites, and as well as biomass. As I said earlier, this is an ongoing research work. So I'm yet to process the data for Adabraka to be able to conclude on the enrichment factor calculations. Let me take this opportunity to appreciate Accra Technical University, where I work, for their support and sponsorship for this PhD study. And then I thank the EPA Ghana immeasurably for granting me the opportunity to have my my attachment to them, followed by having the opportunity to use their equipment in sampling for these 2 years. And in fact, I had no choice than to use their sampling equipment at these sampling locations. I thank them so much. And I say, God bless them all. I thank Mr. Maswa, who is the head of the air monitoring team, and all of them. And I appreciate Ghana Atomic Energy for giving me the space to run my samples at the X-ray lab, and as well as the University of Ghana's Department of Chemistry for every support for this PhD journey. Thank you very much for listening.
We'll just pick a few questions because we are going for dinner at 5. We are almost late. So pick a few questions, and then if you have further questions, you can see them as we move along. Or during the dinner, you can ask the questions, them, and they will answer you. So, can you, and then
Victoria,
come forward.
Thank you very much,
Vic.
sir.
Is Vic there? So Vic, you can come and sit here on the platform, and then we'll pick maybe 2 questions for Vic and 2 questions for Kojo. 2 questions for Vic and 2 questions for Kojo, and they will end there. So please, you don't ask 2 questions, 1.
Thank you, sir.
For others to do.
My question goes to Victoria. Victoria, how do we know those models for air quality forecasting are accurate? How do we know the models are accurate? Thank you.
I did not hear the question. Oh, okay. So that's why we are trying to validate the output. with the ground-based observation. So we use the ground-based observation to validate the model outputs, the forecast from the model. Before we then, if there's a bias, then we try to correct it to improve the accuracy of it.
Okay, thank you so much for the insightful presentations by two of you. My question goes to Victoria. I think you're not sitting down now. Well, my question is, you made mention in your previous slides that the geosatellite and then the data taken from Kampala, there were some overestimations, and then you attributed them to some biases. And then at the end of your slide, you made mention that you are using machine learning to correct the biases. My question is, what biases are you talking about? And how are you going to use the machine learning to correct that bias? Or the bias look a little bit fake.
Okay, so what I said was that I showed the Accra data. That was what I discussed, even though the Kampala data to show the bias. So for the bias within the Accra data, I was saying that especially for April, there was an clear overestimation from the model output. And so when you look at the plot, the observation is quite low, then the model is high. So now the model, once it detects, it has a limitation. Once it detects smoke, it presumes that it stays there for the next 5 days. So that probably could have led to the overestimation. Now, we use the XGBoost algorithm, it's an algorithm, to try to correct the bias, to bridge the bias between them. That's what we did.
Okay, so the first question is saying that the sources for Madabraka. Unfortunately, I've not processed the SRF data that I got from Madabraka, so I can't conclude on that. Sorry. Yeah, it's the same answer that I'll provide, because in fact the process of the data took a bit of time, so I couldn't. I haven't finished. Like I said earlier, it's my PhD work and it's ongoing. The research is ongoing, so I'm here to conclude on those and be able to tell the story at the.
Yes. Good afternoon, and thank you for the presentation. Kojo, my question is, looking at the data that we've presented, the preliminary, it's like it has shown that in all the study areas, the figures, in all the study areas, the figures for the PM, are you getting me? In all the study areas,
Okay.
yes, the PM 2.5 are all reading high. Prior to today, having experience to see a typical study on air quality in Ghana, I was like thinking Ghana was having perfect readings, because this is what is portrayed to the rest of West Africa, or let's say ECOWAS region, to say that Ghana have very strict instruments as in environment protection. What do you think is the current situation? Why is it reading like this if it's not the Hamatan wind blowing into Ghana? Is it because the EPA's mechanisms are not working very well, or what is the situation? Because it's, yeah.
All right. Right. Yeah. Thank you. Right. Thank you very much. Basically, I'll say that it's due to human activities, right? And unfortunately, we don't have so many of these monitors scattered around. So that could also be a limitation. And I think with the revolution of these monitors coming up, the low-cost sensors, that could tell a better story as we move forward. Thank you.